Okay, good morning everyone. Welcome to my explanation video about how to solve a system of linear equations with Cramer's rule. Okay, so let me introduce myself. My name is Muhammad Ramdani. I'm a semester 1 Information System College student at Saputra University. Okay, so first we need to know what is Cramer's rule. Cramer's method is only able to solve the problem of a system equation if the number of unknown variables is equal to the number of equations. So what we can see here, this is the Cramer's rule formula. The formula is quite simple. The formula has x as the variable problem here equals determinant of the numerator in the solution of the variables such as x, y, and z divided by determinant of the coefficient matrix. And also, if there are fewer equations, the determinant will be 0. As we know, when we calculate the determinant of the matrix, the results cannot be as equal as 0, okay? And then if the number of variables is less, then the matrix is not square. As a result, the determinant cannot be calculated. Okay, now we can directly jump into the questions. For example, we have a system of equations here. The first equation is x minus 3y plus 2z equals 4. 2x plus 3y minus z equals 16. And for the last equation here, for x minus 3y minus z equals 19. Now, as we can see here, this is a three variable system linear equation. So now how we do it? So the first step is to change the form here. This is a normal form of the equation, and we can change it into the matrix form. So because this Cramer method is only for matrix, okay? I mean matrix form. And then the next step is find the determinant of matrix A. But in this form, this is a 3 times 3 matrix order. So in here, you can use any method, but in this time, I will only use by Saros method because Saros method is a commonly used method. So now how we do the Saros method. The Saros method, we can add more elements on the right here. This is taken from the first column and two column. So for example here 1 minus 3 2 3 and minus 3 and 4. So to find the determinant, we can multiply the diagonals. The first diagonal are 1 times by 3 times minus 1 plus minus 3 times minus 1 times 4 plus 2 times 2 times 3. Now that is the first multiplication, and then we can divide it, separate this by a minus. Now we can move into the second multiplication here. 4 times 3 times 2. But in the second multiplication, we can only use minus here instead of plus like the left one or the first one. So, and so on. The result is minus 36. So the determinant A here is minus 36. Okay, for the next step here, I will show you how to find the other determinant like determinant x, y, and z. Now, first thing to remember is the key to Cramer's rule is replacing the variable column of interest with the constant column and calculating the determinant. We can then express x and y as equations of two determinants. Oh, I'm sorry, but in this situation, I only use three variables. Okay, so x and z. Okay, so the next step is we will find the value of x first by compiling the dx matrix. So now how we do it? So in the matrix A, we can put matrix B on the left side in the matrix A because the value of x is on the left. Okay, so now the first column here can change into 4, 16, and 19. Okay, this is matrix B. So the next step is we need to find the determinants of the matrix by also the same by using Sarah's method here. So now we have 4 minus 3, 2, 4, minus 3, 16, 3, minus 1, 16, 3, 19, minus 3, minus 1, 19, minus 3. So after we calculate the determinant here, we can get the solution here. So the determinant of the dx is minus 225. And next step, we're gonna find the y variable. The methods are also the same with the previous one, but to find the y, we can change the column 2 here on the middle one into the matrix B because the value of y is on the center of the equation. So now we have 1, 4, 2, 2, 16, minus 1, 4, 19, and minus 1. And next we also it's the same. We determine the determinant here. And after we calculate the determinant here, we can get the determinant of dy matrix is minus 57. And the last one is the determinant of z variable. So our methods are also the same, but for the z is by putting the B matrix on the right side of the matrix A. So now we have 1, minus 3, 4, 2, 3, 16, 4, minus 3, and 19. So after we calculate the determinant here, also the same as the before, we can get the value of z variable, the determinant of z variable is minus 45. So after we calculate all of the determinants here, we can get all the solution to the system of the equation. The first one is x equals determinant x divided by determinant equals the determinant x is minus 225 divided by minus 36 equals 6.25. And the y variable equals the determinant y divided by determinant equals minus 57 divided by minus 36 equals 1.58. And the last one is z equals determinant z divided by determinant equals minus 45 divided by minus 36 equals 1.25. Okay, so this is our final answer here. But when we get this, we must prove it. Is it true or not by putting all of these values here on in the first equation here. X minus 3y plus 2z equals 4. So now we have 6.25 minus 3 times by 1.58 plus 2 times 1.25 equals 4. So now we have the same value here. Okay, so this is our true because the values are equals here. Okay, I think that's it for from me. I hope my explanation might be helps you. And until next time, bye bye.